so let's start with a shape. Let's start with a circle here. So I have a circle, and I'm going to define something in this circle. I'm going to tell you that the radius of this circle is 1 unit. I don't care whether it's miles, inches, feet, centimeters. The radius is 1. The circumference of a circle, the formula for the circumference of a circle is 2 pi r. So I start here at 0, and I go all the way around the circumference of this circle. How far have I gone? Well, I have gone 2 pi times the radius. Well, the radius is 1. So I have gone a distance of 2 pi. So that being the case, if it's 2 pi to go all the way around the circle, what if I only go halfway around the circle? So I go to this point right there. Well, if it's 2 pi to go all the way around the circle, to go halfway around the circle, it's a distance of pi. Again, because our radius is 1. It's a distance of pi. Now I'm going to take this top half of the circle, and I'm going to divide it into some pieces. I'm going to divide it into 6 equal pieces. Oh, we're relatively equal. I mean, you know, I'm drawing it by hand, so I can't be perfect here. But I'm going to draw it into 6 pieces. If I've drawn it into 6 pieces, and I know that the distance from here to here is a distance of pi, then the distance from here to here, divided into 6 pieces, is 1/6 of a pi. So it's 1/6 pi, but it's better written as pi over 6. And if I go another little segment, so I've gone this segment here, now I'm going to go this segment here. Well, if this one here is 1/6 of a pi, and I've done it twice, then this one here is 2/6 of a pi. But 2/6 is a non-simplified fraction, so I'm going to change that to pi over 3, 1/3 pi. Now over here, I have 3/6 of a pi. Well, 3/6 is 1/2, so we can call that pi over 2. And over here, I have 4/6 of a pi. See, I've gone 1, 2, 3, 4/6 of a pi. So that's 4/6 of a pi, which I can simplify into 2 pi over 3. That's 2/3 pi. And here I have 5/6 of a pi. And back over here, I have 6/6 of a pi, which, of course, is pi. Let's just finish off this circle. Again, I'll divide my bottom half into 6 pieces, as equal as I can. So 6/6 of a pi gives way to 7/6 of a pi. And 8/6 of a pi is the same thing as 4/3 of a pi. And 9/6 of a pi is the same thing as 3 pi over 2. And 10/6 of a pi is the same thing as 5 pi over 3. And then we have 11/6 over pi. I'm sorry, 11 pi over 6, 11/6 of a pi. And then we're back here to 12/6 of a pi, which of course is 2 pi. So we've divided up our circle into 6ths. Now each of these are going to be very special. We're going to give them numbers, again, different kind of numbers in a little bit. But this is really important to memorize. You really don't even need to memorize it. You just kind of follow the logic that we just did. You should be able to pencil in each one of these numbers around the circle. Now, we know that a circle has 360 degrees. Degrees is a very random unit of measurement. I don't know where it came from. I'm sure we could look it up and do a little report on it. But it doesn't really mean anything except that we use it all the time. And if it's 360 degrees all the way around the circle, then halfway around the circle, it's 180 degrees. And if I divided 180 degrees into 6 pieces, that means each little one of these slices is a 30-degree angle. This 30-degree angle will become important in another minute or two, but for right now, I'm going to propose a different way of measuring angles. I don't want to measure angles in degrees. I want to measure angles in something that I'm going to call a radian. So a radian is the length of the radius. Well, I know that if I go from here and I go all the way around the circle, I hope you can see me drawing this, I think you can. If I go all the way around the circle, we've already determined that that is a distance of 2 pi r. Well, r is my length of my radius. That is a radian. So to go all the way around the circle is 2 pi radians. If I go halfway around the circle, let's use a different color. If I go halfway around the circle, I haven't gone 2 pi radians, I've gone 1 pi radian. If I go just this far around the circle, how many radians have I gone? I've gone pi over 6 radians. So one definition of a radian is the length of the arc of a circle in terms of compared to the length of the radius of the circle. 2 pi radiuses to go all the way around the circle, 1/6 of a pi radiuses to go that far. Now, if I change the length of my radius and I say it's no longer 1, but it's 2, well, that's going to change the distance I have to travel to get around my circle, because instead of being 2 pi times 1, which it was before, it's going to be 2 pi times 2, which is now the length of my new radius. But the distance around my circle, in terms of radians, is still going to be 2 pi radians. Yes, it's twice as long of a distance, but I'm dividing it by 2 because the unit measurement of my radius is 2 now, it's not 1. So it's still going to be 2 pi radians. So I would have 4 pi as my distance, but my radian is measure 2, so that's still going to be 2 pi radians. Similarly, from this spot over here, around the circle, to that spot over there, even though it's a longer distance if my radius is 2, it's still pi radians. And the distance from here, from the beginning point to there, is still pi over 6 radians. The measurement of the arc around the circle in terms of radians doesn't change just because I've changed the size of my radius. So what this leads me to is a very important concept. I have here a 30-degree angle. That 30-degree angle can be expressed not only in degrees, it can also be expressed in radians. So, let's extend this here a little bit. A 30-degree angle is the same thing. It's equal to a pi over 6 angle. 30 degrees, pi over 6 radians. And that doesn't matter how large or how small our circle is, a 30-degree angle is always going to be pi over 6 radians. So another thing that leads me to is a very easy way to change an angle from radians into degrees. Let's extend it a little bit more here. I'm going to make myself just a new circle for just a minute. Okay. I know that this angle right here is 180 degrees. And I also know that that angle there is pi radians. So I can say 180 degrees is equal to pi, and we usually leave off the word radians, it's too cumbersome. But if I say it like this, pi, and I tell you I'm working in radians, you know that it's radians. So if 180 degrees is equal to pi radians, that means that 180 degrees divided by pi, since they are equal, is equal to 1. And this gives us a way to change any angle from degrees into radians. So let's say, for example, I have a 60-degree angle, and I want to change it into radians. Well, I can multiply 60 degrees times 1, can't I? And I'd still get 60 degrees. But I want my 1 to be in the form of pi radians over 180 degrees. So just like this, pi over 180 degrees is also equal to 1. Well, what's this? I have 60 over 180. That turns into 1 over 3. So that leaves me with pi over 3. Well, take a look at our unit circle that we did before. 30 degrees, add another 30 degrees, I have 60 degrees. What do you know? The radian measurement of 60 degrees is pi over 3. Let's try it a different way. Let's say that I have an angle that is 5 pi, let's not use that one, let's use a little bit different one. I'm going to have an angle that is 3 pi over 2 radians, and I want to know what it is in degrees. Well, I'll take 3 pi over 2, and I'm going to multiply it by 180 degrees over pi radians. Well, okay, that's fine. I can see that my pi's cancel out. My 2 goes into 180 90 times. So I have 3 times 90 degrees. That's 270 degrees. Let's go back to our unit circle. Well, I know that from this point here to that point there is 180 degrees. And if I go another 90 degrees, 180 plus 90 is 270 degrees. 3 pi over 2, 270 degrees. So it's very easy to change from radians to degrees just by using this concept right here. And when you're doing it, when you're changing from degrees into radians, you make sure that you use this one, because you want the radians on the top. And when you want to go from radians to degrees, you use this one, because you want the degrees on top to be your final unit of measurement.